Hello everyone, welcome back to my channel. So in this video we would be discussing about priority scheduling, and priority scheduling is also of two types, preemptive and non-preemptive. So firstly let us discuss about the preemptive one. So in priority scheduling what we basically do is that the process with the highest priority gets allocated to the CPU first. So first of all, let's start for this with time t is equal to 0. So at time t is equal to 0 we only have P0, so it gets the time allocated. Now it gets completed at 3. Now after time t is equal to 3 we have all the 3 processes in the CPU, as we have 1, 2 and 3 as the arrival time. So in this we'll see that P2 has the highest priority, so we'll give it to P2 first. Then when P2 finishes, as it has burst time of 8, so it will finish at 11. Then after P2 we'll have P1 and P3 remaining, and in that we have P3 with the higher priority, so P3 gets allocated first and it has a burst time of 6, so it will get completed at time 17. Then we have only one of them left, that is P1. So P1 has a burst time of 5, so it gets completed at 22. This is P1. Now let's talk about the turnaround time. So turnaround time is the completion time minus the arrival time. So for P0 the completion time is 3, so 3 minus 0 is 3. Then for P1 the completion time is 22, so 22 minus 1, 21. Then for P2 the completion time is 11, and 11 minus 2 is 9. Then for P3 the completion time is 17, so 17 minus 3 is equal to 14. Now let's calculate the waiting time, which is turnaround time minus the burst time. So we have 0, 16, 1 and 18. So this is the priority scheduling in preemptive, non-preemptive way. So now we'll discuss about the preemptive way for priority scheduling. So basically in preemptive what we do is, let's understand with this example again. So at time 0 we have only P0 with us, so we allocate it. Now at time 1 P1 enters, but it has a lower priority, so we still continue with P0. Now at time 2 P2 enters, which has a higher priority, that is of 15, so we preempt P0 and allocate P2. So after that, since P2 has a higher priority, so at time 3 when P3 enters, it has a priority of 12, which is still lower than P2, so P2 continues. And then when P2 continues, still 15, so it will finish at, sorry, the burst time is 8, so it will finish at 10. So P2 finishes at 10. Now then after all the processes have arrived, the non-preemptive one can be also implied here. Basically in even preemptive algorithm, when all the processes have arrived, we can do it as the non-preemptive one. It would be similar because all the processes have already arrived. So now we have remaining P0, P2 and P3. So P3 has the highest priority, so we'll first have P3 here. So P3 completes in 6 units of time, so it will complete at 16. Then we have P0 and P1 remaining. So P0 has a higher priority, so 2 units of time of P0 have already been consumed, so only 1, so P0 completes at 17. Then finally we have P1, which takes 5 units of time, so it completes at 22. Now let's talk about the turnaround time. So turnaround time for P0 would be 17 minus 0, 17. Then for P1 it would be 22 minus 1, which is 21. Then for P2 it would be 10 minus 2, which would be 8. And then for P3 it would be 16 minus 3, that would be 13. Now let's calculate the waiting time. So this would be 14, then 16, 0 and 7. Now we can see that the process with the highest priority always has a waiting time of 0 in preemptive priority scheduling. Now let's discuss response time here. So for P0 we can see that it came at 0 and got allocated at 0 as well. So it basically, the response time for P0 would be 0. Then for P1 it came at 1 but got the time allocated at, got the CPU allocated at 17. So its response time would be 16. Now for P2 it came at 2 and got the response at 2 as well. That is, it got allocated to the CPU as at 2 as well. So its response time would be 0. Then for P3 it arrives at 3 but gets allocated at 10. So the response time would be 7. Now this is the preemptive priority scheduling. Now let's discuss the demerit of priority scheduling. So the demerit of priority scheduling is starvation. Starvation of low priority process. So what basically happens is that if a low priority process is there, then higher priority processes might come and they get allocated to the CPU and their execution is done. But this low priority process stays starved because it doesn't get to the CPU. So the solution for this starvation is aging. Now what basically is aging? So aging says that as the process is waiting, with each waiting time its priority should be increased by bit so that it gets a higher priority and gets allocated to the CPU. So there is no starvation. So that's the solution for starvation. And that's it for priority scheduling. We'll meet in the next video with another scheduling algorithm.